Hey YouTube, crypto community, friends, family, check out this new hoodie. Katie bought it for me with Eternity tokens. I dig it. So, you may or may not know, Eternity is built on Erlang, which is a functional programming language. And it's a really great language for blockchain, and they have some of the creators of the language and the most experienced Erlang developers working for Eternity on the protocol level. And I saw this video from Ivan on Tech yesterday where he talked about Erlang and functional programming language. He was mostly talking about Tezos and Cardano blockchains, which used a little more prominent than Eternity and also use functional programming. And he thinks functional blockchain languages are going to be very important for reasons that I will let him explain. So I've got about a 10-minute clip from yesterday's Ivan on Tech Good Morning Crypto video. Highly recommend subscribing to Ivan on Tech. He's one of the most respected, well-known blockchain people in the space. So I've got a 10-minute clip. I didn't bother reaching out to Ivan because I'm a very small channel, so I hope he doesn't mind me using his clip. It's promotion for his website, it's promotion for his academy, which he runs a educational academy with his partner Philip. So really great. I love this clip. It's going to explain the benefits of functional programming and Erlang, give you a little background. So he's not talking about Eternity specifically, but I felt this was very relevant to Eternity and explains why, Eternity used it. And Eternity built from the ground up with Erlang to leverage it. And that's part of why they are such a high performance blockchain. So thank you, Ivan. If you don't like it, I'll take the video down, but let's get into it and I'll see you afterwards and talk a little bit about it. All right, cheers.
Second part of the video, I want to focus on the fact that you need to understand what functional programming is. Let me know if you have an idea of what functional programming even is in the chat. I want to get an indication of my audience, how much guys you know. But as an introduction to functional programming, it's important to note that WhatsApp used functional programming, and it was one of their pieces, one of their ingredients of their success, And basically, they only had 50 engineers to support an infrastructure and to support an app of 900 million users. And so if you understand how WhatsApp did it and how they utilized this situation with functional programming, you can see where smart contracts are going and how smart contracts will be utilizing functional programming more and more. But anyway, this is an old article from 2015, but the knowledge is still here. The knowledge is still very important and many people still don't understand it. Basically, when the company was acquired by Facebook, when WhatsApp was acquired by Facebook, they only had 35 engineers and they had 450 million users. Right now, at the time of this article, they had like 900 million and only 45 engineers. So what's important to note is that part of the trick was using a functional programming language called Erlang. And you realize that by using Erlang, they could really make their development process efficient. And especially when you have a lot of applications and a lot of code that does concurrent processing. What does it mean? It means that many different things are happening at the same time. Concurrent programming and concurrent development is basically when you have a chat application, when you have a blockchain network, whenever you have a situation, an architecture in which many players are operating at the same time independently, they're all sending messages to each other, they're all trying to reach some kind of consensus. So you see that Erlang used in WhatsApp made a lot of sense, and also functional programming, because Erlang is a functional programming language, makes a lot of sense in crypto because it's kind of the same. It's the same thing where you have a lot of concurrency, you have a lot of people using the same network at the same time. So you understand that WhatsApp really pushed this change towards functional programming, and it helped them a lot with concurrency. Now, Facebook used also Haskell to do things like concurrency. So Haskell is another programming language. And you know that, for example, Cardano, they have Plutus, which is their programming language, and Plutus is basically Haskell. They took Haskell, they changed a few things. So Haskell is another very important functional programming language. It's important to note as well that Haskell and in particular Erlang is a product from Ericsson. And you know that the head of blockchain at Ericsson is our alumni from our academy, guys. So you see, we do have extremely heavyweight people in the industry taking our courses. And this guy Giovanni, he's head of blockchain at Ericsson here in Sweden. It's a multi-billion international tech company, and he has a team of 15-20 people under him. And without our academy, he would not really be in that position. So definitely check out his testimonial. But you see that Ericsson developed Erlang back in the 80s because they needed it for telecom. Telecom is also a situation in which you have a lot of concurrency. You have a lot of different people calling, they're calling each other, they're calling while someone else is already calling that person. So you need a lot of that logic. So instead of inventing a language and then figuring out what to do with it, they set out to invent language which solved a very specific problem. And this is basically what Ericsson did with Erlang. They had this issue with concurrency. They basically were engineering the new generation of telecom, and they invented Erlang. Now, what's important to note is that it has some drawbacks, Erlang and Haskell, and the fact that most people don't really program in functional programming. It's a bit more difficult to find developers for functional programming, but once you find them, you don't need a lot. And usually they're very skilled. You do see a lot of so-called hobby programmers in normal programming languages like C++ or Java or JavaScript, because it's easy to go, for example, from JavaScript to C++, although you don't really understand C++, but you can make it look like you understand. I mean, you could pass easy programming interviews if you just know a bit of Java and you can like code simple C++, but you don't really know C++ in depth, but you can still get away with it if your interviewer is not digging deep enough. Now, with Erlang and Haskell and functional programming languages, it's difficult. I mean, you either have someone that knows functional programming or don't. It's very difficult to kind of, fake that you are a functional developer. And all in all, so there are pros and cons, but the pros in many cases outweigh the cons. Now, I just want to give you a graphical, a visual representation of how this difference looks like. Between, for example, Java, there is a very popular object-oriented programming that people normally use in an imperative way. And imperative basically means that you tell the computer what to do step by step. So, for example, here is how you could do a list in Java. You first create this object, which is the list, and then you add items into the list. So you write list add 1, list add 2, list add 3. So this is how you create a list, and then you add 1, 2, 3 into the list. Now, with functional programming, you can really concatenate it a lot to just, list, and then in one line, you just write it. And while it's possible to do similar things in Java as well, it's just not as common. I mean, an even better example is this. Basically, how you do Fibonacci calculation in Java versus Haskell. Haskell is just one line, and it's using just functions. This is pure functions. And this means that when you use pure functions like that, it's very easy to create mathematical proofs for your code. So this is a Fibonacci calculation in Haskell. This is just this one line right here. And this is a Fibonacci calculation in Java, like this. So here you actually need to create this, list. You need to add the first elements of the list, and then you need to create a loop, and then you need to calculate everything step by step. While here it's more high level, you just use mathematical functions and you embed all of the logic in this mathematical kind of expression. So you're not telling the computer what to do step by step by step. You're thinking more high level. You're thinking more mathematically. You're thinking more in terms of functions and not in terms of individual operations like you do more in Java normally. Now, obviously, they have baked in a bit of functional programming in Java. I mean, you could use similar things in Java as well. They're trying to bake in things like zip or things like map in Java. It's possible, but it's just not that common compared to, for example, programming languages that are only purely functional, like Haskell or Erlang. Anyway, what does it mean? Why is it so important to have these mathematical notations, and why is it so important to have for blockchain at the end of the day? Because look, we're dealing with mission critical software. We're dealing with extreme mission critical software handling hundreds of millions of dollars. And obviously, it's very important to understand the fact that when you're doing that, it's key to prove that your program does what it is supposed to do. And doesn't end up in some kind of weird state where, for example, the funds are inaccessible because a library has been nuked, like we saw with Parity. So if only Parity, for example, wrote their code in a functional approach, they used a functional programming language which they couldn't. At the end of the day, still they created this contract which was able to end up in a state where a dependency was missing because somebody just shut it off because they had a bug in who could control and turn on and off that smart contract, which was very critical to Parity wallets. It ended up with the fact that hundreds of millions of dollars were frozen in Parity wallets, and this could have been avoided if you just had functional programming and you had so-called formal verification. So what is formal verification? Formal verification means that you have mathematical proofs and you show that your code will not end up in this and this weird state, and that it will never end up in a state where the money is being taken out without the permission of the users or without some specific rules that is being proved by that mathematical proof. So in functional programming, it's way easier. And while it's still possible to do this mathematical proofs in Java and do formal verification in C++ or where it's possible. It's just not easy. And if you want to learn Cardano programming, you want to get into functional programming, we have compiled cardanoprogramming.com as a starter. So we teach you the basics of functional programming in Plutus, and you can even run an application in the playground, like a hello world application. If you want to get your hands dirty and to really start doing this, go to cardanoprogramming.com and you will get an introduction. Because look, at the end of the day, we don't only want to be here talking about it, we also want to be here implementing and teaching how it really works. And right now we're actually in talks with Cardano Foundation to do a course on in Academy. So that will be in 2020. So we will have here in our tracks a functional programming course with Cardano and with Tezos, because Tezos is the second big project that is also using functional approach. And you should check out my interview with Charles Hoskinson just a few days ago, where we discussed functional programming and Cardano. The thing is that I really don't like that there is this conflict between Tezos and Cardano, and I get why, because they're both within the functional programming space, and they're both kind of doing the same thing in terms of introducing formal verifications, and they're both basically exactly at the same place in CoinMarketCap. Cardano was a few days back above Tezos. Now Tezos has surpassed Cardano. And you realize that there is this unnecessary conflict that really I don't appreciate. Because look, they're both interesting. And they both add a lot of innovation to the space. So that is why I don't really like when they are doing this kinds of fighting and really using their similarities as a reason to get into conflict. But this is kind of the situation with all cryptos. People get extremely in their projects. They have money invested, they have their emotions invested, they have everything invested in one coin, and then when somebody says anything against that, they get what is it called? It's tribalism. But what do I want to say? They become zealous. Is that how we say it? Anyway, guys, you get my point. Now, so Cardano and Tezos are the two projects that I'm looking at in terms of bringing a whole new paradigm of programming smart contracts, and it is going to be big in 2020, I think. Absolutely. And then, of course, another project that...
Man, I love that guy. Ivan on Tech is cool. He's actually one of the inspirations for me to make this channel better, because he's such a good speaker. He's such a good educator. He knows a lot. He's actually a programmer, unlike myself. I have taken some of his academy. Pretty cool, but just programming is not really for me. I can't look at a computer screen. I have very bad vision, so it makes it hard. But so I have to agree with him. This whole bashing, I'm not going to bash Tezos, I'm not going to bash Cardano, even though they still haven't launched. I think Eternity could be one of the top players in the space because they're built using functional language, especially Erlang, unlike Cardano, which is on Haskell, etc. So I think it comes down to a couple things: performance and the formal verification. where you can mathematically prove something is going to happen and you don't have these unwanted side effects. But, you know, one of the problems is it's a little bit different programming style, and as far as I can tell, there's not as many programmers that know functional programming. More of them are imperative, like the JavaScript and the C++. So that is a small problem, but if you need education, Eternity has put out a lot of education tutorials. They just put out an app boilerplate. I would recommend the documentation hub for Eternity. So I hope you all learned something. Please leave a comment. Subscribe to Ivan, shout out. And if you like the video, you can leave me a tip at josh.chain. Thank you very much and have a good day.